Hey guys, in this video I just want to do kind of a shop update, and if you don't follow me on Instagram or Facebook, there's a couple things you may have missed, so I just thought I'd throw this together really fast. This is my jet bandsaw you're looking at, and I've mentioned it in a couple other videos, but I don't think I've ever showed footage of it. I bought this years ago and I got it for dirt cheap, like $150 or something. I think it retails for over $1,000. Jet still offers this bandsaw. It's model HVBS 7MW. I think it's a 7x12. It's had a ton of problems and I finally got it fixed. I actually posted a video, I don't know, a long time ago of me cutting through a big chunk of aluminum using my reciprocating saw, and I was lamenting selling my old Harbor Freight bandsaw. In fact, check the cards right here for that Harbor Freight bandsaw review video. I think it was the first video I ever posted on YouTube. And then again right here there's another card for that video where I'm cutting with the reciprocating saw. It's not very interesting, but I will show you one thing I cut on this recently, and that was an axle shaft. You can see how thick the induction hardening is on this, and it ended up trashing the blade. It still works in aluminum, but not very well. You can see I've got a big pile of aluminum chips right there. Anyway, one thing I've also started to do is I disassembled the hydraulic cylinder. There's a downfeed cylinder, and I've got it all tore apart, but I don't know how to fix it. So let me show you that real fast. So this is what the cylinder looks like, and unfortunately Jet no longer offers the repair kit for this cylinder. They do offer a repair kit for the new version, and the new version, from the pictures I found all over the internet, it looks identical to the old version, but of course that doesn't mean the part numbers inside are going to match. I mean, the part numbers are all listed differently. Maybe they did that just to throw people off. I'm not really sure. Basically, I can compress it and decompress it with my hand. It doesn't really hold a lot of resistance. It definitely won't hold up the head of the bandsaw. And it's not leaking any oil, so I believe that means this seal and this O-ring, this is called a gland if I'm remembering correctly. This must be okay, because I believe if either of these leak, I would get oil on the floor, you know, but I don't. So that means it's got to be something on this end. Now, I'm wondering, maybe I can just take measurements of this rubber part here and this other rubber thing. I don't know what they're called. And then go to like an industrial supply website and order, you know, parts that match. I don't know. If any of you have experience, I'd love to hear your solution. The other thing it could be is this, this valve. Because whether the valve is open or closed, I get the same result. Maybe that means it is the valve. Well, no, because if the valve was locked and it could still bypass the cylinder or the piston. So it's got to be the piston or the valve, right? These fittings are some weird metric size. I have no idea what they are. I measured them though, and they're not standard, you know, American pipe thread sizes. So I don't know what they are. Maybe I can just get this part. This part is also offered by Jet for the newer cylinders, but not for this cylinder. Well, maybe they are for this cylinder. You know what, I need to do more research. Anyway, I'd love to hear your opinion on this stuff. I'd like to get it fixed. There's two fun things happening with the mill. The first one is flood coolant, and you can see that's coming along a little bit. I'm going to show you what that looks like. That is a 1/2-inch ID hose, and you can see it puts out almost a scary amount of volume. I'm pretty sure that's more volume than what I get through my municipal water when I turn the hose on outside. I don't think I get quite as much volume as I get with my flood coolant, so that should be interesting. The second thing is I have burned up another motor, including the stock motor. This is the second DC motor I've destroyed. This one's rated at 2.8 horsepower. That's both peak and continuous duty. 130 volts, almost 2100 watts, which is about 16 amps at 130 volts. I had it running at about 110 volts, and yeah, it just totally overheated and caught fire. I was machining this block of aluminum right here, and you can see the chips coming off were just, I mean, really nice. I was doing a 1 1/4 inch depth of cut with this 3/8 high-speed steel end mill. It's 5% step over, which is about 19 thou, just over 2 thou per tooth chip load, and it works out to about 0.7 cubic inches per minute, I believe. And it was cutting along really well. No chatter, sounded great, and then all of a sudden it started to sound like it was bogging down, so I quickly hit the feed override. And I wish I would have thought to look up at the load meter, but I didn't. And then it started to sound like it was slowing down even more. And just as I went to hit the e-stop, the fuse blew in my DC drive, and I glanced up and there was fire coming out of the top of the motor. So it's completely toast. I've already bought a new motor and it should be here next week. I'll tell you a little bit more about that later. I will say I'm going AC 3-phase, but we'll talk more about that motor in a separate video. So real fast, this is the DC drive. You can see one of the fuses right there, that gray fuse. That was the one that blew. There happens to be a fuse in it now because I was doing some testing. The fuse that should be right there next to this big horsepower resistor, that fuse was fine. The problem is you're supposed to run a 25 amp fuse on this side, which is what I had, and that's what popped. But on this side, you're supposed to run a fuse that's rated for your motor. Well, since mine's a 16 amp motor, I probably should have been running, well, a 15 amp fuse probably would have saved my butt. A 12 amp fuse maybe even, you know, if I didn't want to overload it too much. But no, like a moron, I had the original 25 amp fuse in there, and 25 amps is way too big for that motor, and that's why I burned it up. So the DC drive will be coming out of this box, and for now I'll be using this AC drive to power both my lathe and my mill. I'll just use a series of relays to switch in between which motors are getting the power. That'll work fine for now. Eventually I will be buying a second VFD, and we'll talk about that more later when I show you the motor in a future video. There's not too much going on with the lathe. I'm editing the video about limit switches right now, and it's pretty short video. There's really not much to it. And then I think that's the last video about the lathe CNC conversion. I'm still going to make a video about the VFD, the Hanyang VFD. I'll be going over that, and then we'll talk about limit switches a little bit more, well, rather soft limits in my Linux CNC series, which those of you who are waiting anxiously for Linux CNC, and I know there are a few of you, I've started reshooting that series. I already had filmed, I think, 5 videos, and I have a list of, I don't know, maybe 10 that I want to do, but I didn't like the way I was filming those, and I just didn't like it at all. So I'm redoing it. I've already got the first one done. I'll be making that live probably in the next couple of weeks, I hope. I'll start rolling those out slowly. There's probably going to be 5 kind of in a row-ish, and then probably some more after that if people have questions. You guys know, if you ever have a question and you want to know something, you know, and if I can help, I'll make a video for you. I have no problem doing it. Anyway, that's it for this video. Thanks for watching. I'll see you in the next one.